So we have a few problems. Well, actually, we have a couple of problems, not just a few. Okay, well, first of all, we do not move until we have an issue with this. Let's take a look. This being kinematic. Yeah, okay, that's not as bad. But we can do this better. First of all, we are flying, and we have a few more issues with this, for what we can see. So let's fix all those issues. First of all, I'd like to let's get rid of the nav mesh agent. At least for now, it doesn't really do anything. Then let's start clearing up our scripts as well. So let's see, we do not use the nav mesh agent anymore. We have the, okay. So now I'm going to go on to our handle ground. Let's say ground, and let's see. Nav sample position. Okay, so this is useless now. Nav hit nav point. This is as well useless. So when we're hitting now something down, we're going to say is grounded equals true. Otherwise, if you're not on the grounded, then everything is looking fine. Okay. Then this can be a sphere cast, and that will be origin. We have the origin out hit. Radius should be here, and I'll do like 0.4. Or should be down here. Yeah, that's a little bit confusing. Origin, float, radius. Now, I don't know who's the genius that thought origin and direction should be separated from the radius, but whatever. Okay. So this will now doing a sphere cast down, and it's going to be a little bit more open as to what it finds, and it takes it as ground. Okay, so this should be working fine. The other thing that I would like to do, we're getting a target position, and we're finding a target position. We're not actually doing anything with this, but I would like to place the object right onto the position we have, we find, or at least affect the Y, so you can go up and down stairs and small objects without having a lot of issues. So let's see, we have our grounded, and we have this over here. We have a normal point. Let's start deleting a lot of this, because these are useless anyway, and this as well. We're still moving with physics. Whatever we do, we are still moving with physics. So this is as well. Okay, so let's delete that as well. Let's delete this as well. Okay. Okay, and so here's the thing. We have our move character. First of all, I'm going to assign the delta as a private variable, or a variable that is inside here, because we're going to be changing from where we're getting these values and how we're getting them. Okay, so ignore the combo for now. We have our move character. I'm going to drop it inside update, or actually we're using this from the controller, so we're going to affect where these are all handled slightly differently. So let's go back. For now, let's just do time.delta time. Okay, then back to the controller. We have our controller is interacting. Okay, this can just stay as they are. And I think with handle rotation, we need to change a few things. Instead of going forward, going towards where the movement is actually much more it makes a little bit more sense, to be honest. So move amount, rotate direction. Handle rotation needs to get delta, and the rotate direction move character should be camera transform rotate direction. Okay, so that's correct as well, but we're going to change the velocity to be based off, instead of forward, to be based off the rotate direction multiplied by move amount by movement speed, and all that needs to be subdivided. Actually, I think we are adding the speed or something, and I think we don't need the move amount, we just need the movement speed now. Let's go upwards. Rotate direction, okay. So we're just getting the raw values to this. Rotate direction, horizontal or vertical, we already have this, so that means we don't need the move amount. We have the rotate direction. Then we're going to have to go over here by movement speed and subdivide it by time dot delta time, or by delta, because we might be using the fixed delta time. Okay, so that will be your target velocity, which then you're going to be passing as a reference value, and if you're grounded, you're going to project that as a hit normal, and then bring that back as your target velocity. Okay, handle animations can just stay like that. Okay, so I think that should do it for the most part, but I want to change the way we are updating our move character. So first of all, we're going to have to make the execution orders. So let's make an enum, not order, and we have fixed update, and of course late update. We can use this for later things, but for now we're going to all use this. And we're going to say execution order. Do we have this? It's just a class. What? Oh, yeah. Let's say movement execution order, because we're also going to be using this to find when's the correct place to actually move our camera. So we have update, and we want to have fixed update as well. If controller is null, it means it's not instance yet, so we're going to just drop it there. Handle input, even if we add them onto, even if we add them into fixed update, they still only update inside update, so it doesn't matter. Okay, so I'm just going to copy this and say void handle movement and drop them here. One thing though, we need to have vertical and horizontal, so this can just be class variables. Okay. Let's see then, since these are class variables now, this is useless. Okay, now I want to be passing the delta for this, because if we are updating with fixed update, then we should be passing fixed delta. So if move execution is fixed update, handle movement, time dot fixed delta time, and let's copy this, and if we are inside update, then it will be update delta time. Okay, and that handles our movement. Now, spoiler alert, I already know in fixed update is what we should be moving at. Okay, so rotate direction now is going to be a movement direction, to be honest. Move character, and let's do move direction. And vertical and horizontal now, I don't think there is actually a need for them to be passed through this, but it doesn't hurt either way, so whatever, because we have handle animations and so on and so on. So we're just going to keep it like this. So let's find the errors first of all. And controller.delta, yeah, okay. For this, I'm just going to take my time.delta time. I'm just going to use this, to be honest. It doesn't have to always be that. And instead of controller, we just need to be passing our velocity. And that will be your controller. .velocity, okay, we need to fix that. Then we're not going to be having, actually, you know what, instead of doing it this way, I'm just going to say public vector3 delta position, and I'm just going to add this as delta position equals that, and we're going to handle it through the controller instead of adding it through here. Okay. Don't remember why you have this, but it's probably for something. Anyway, minimize that. Let's see where other errors are. Float, okay, for this, just screw that. Let's say time.delta time. Okay. So we have our controller. Let's close the rigid body. And the capsule collider, we'll fix the capsule collider in a bit. Okay, close the starting course, and let's see, we have our input manager. I know now that they are, by default, it's going to be fixed update. And we're not moving because our rigid body is kinematic. Okay, now that's way too fast, because I think we messed up the movement speed. But first, let's check what movement speed we have here. Yeah, it's by 4. So let's say 1, and then onto our controller. That will be delta by movement speed. And I guess 1 is way too small. Let's do maybe movements. Let's just try this without the delta, because I think it still goes, yeah, okay. What? Let's do 10 here. Don't know why we're suddenly off the ground. That's weird. Capsule collider is of course down, and I think maybe it's because of that. Let's see. The capsule collider is slightly above ground. Let's set this to 1, and then let's go under our controller. I think it's because it's projected. I don't know. We'll see. Reference value, target velocity. Let's see. Do we do anything with V? Yeah, okay. We do a few stuff which we don't care to do. So screw that. And screw that. Direction dot normalize. Where do you get the direction? There. Yeah, no, that's all useless. That's all useless. Maybe not. We can keep that. Okay, so we're doing a sphere cast down. Actually, for now, let's change this into a simple raycast. And if we have problems, then we're going to just change it. Okay, is grounded true? Otherwise, if it's grounded, then it's grounded false. Let's see. Yeah, okay. We don't need to be passing that. We can just check now at the start of the frame of this. And let's hit play. And yeah, we're moving. Let's close Gizmos to see how we're moving. And 10 is 2. And you can see there's some jittering. And that's coming from this. Because we are updating in fixed update, in late update. Okay. Now we have some proper speed. Let's set this to 5. Okay, now the other important thing that I want to do is basically keep this guy off the ground. So if there is small differences in the elevation, for example, you might just have something like this. Then you're going to have problems. Obviously that can just be a rock or whatever. Okay, and then you start flying off. Yeah, okay, maybe it's not the best example, but doesn't actually happen right now. But yeah, trust me, we need to be off the ground. Now, the other thing that we need to have and is when you are basically flying, we're not landing anymore. And we're also falling too slow for whatever reason. So, with that in mind, if it's grounded, check ground. Well, anyway, I want to make it so the controller is actually flying. The capsule collider is actually high enough. So I'm going to change the height to 1, and I think the radius can just be even smaller. 25 should do it. Okay, so the trick with this is that we actually need to have proper placement now. So we're going to assign first of all the current position, and then once you're grounded, current position is going to be hit dot point. Then after we've added our velocity, we're going to be doing a lerp from your own transfer position to the current position. Okay, and all that by delta subdivided by a fraction. That fraction I'm just going to set as public float grounded speed. I'm just going to keep it 0.1 f. Let's see, I think some of them we don't use anymore, so we can delete. Okay, rate distance, and we should probably debug some of this. Okay, let's leave the rest. Grounded speed, and then on start or on init for this, current position will be just mtransfer.position. So now we'll be off the ground. Let's add the debug logs and debug rays actually. If we do not have them, we have the first one by distance. This will be public, to be honest, and this will be public as well. So public float grounded distance ray, and I'm going to set it 0.5. We'll not use any of this anymore, so let's delete this as well. So grounded distance ray, let's find it. Should be here. Okay, so we should do something to eliminate those jumps, which is to basically just move the grounded distance ray, just make it higher. Okay, and that's it. You're not flying anymore. There is a jump, obviously, in the camera mostly, but that just means we just need to change the speed we're moving with the camera. But it's now way more fluid, to be honest. And I don't like how it looks kind of slow for the animations, which is terrible. So let's say we change the speed to be a bit higher than what it is now. Well, at least now it looks a bit better. Yeah, that's more like it. Okay, and you can start falling and you can moving. So now you have a properly working controller with proper movement. There's a few things like this, but you know, you get the idea. You can always just change the position of the player. The position of the collider, actually, to be honest. Okay, so I think that's the movement we're going to... Oops, what was that? Ground down distance on the air, that will be 0.4. Oh, ground down distance ray is 0.5. So let's set that to 1. Okay, now we're talking. Perfect. So set this to 1. Ground distance on rail, let's just keep it at 0.5 actually, or 0.4. Because we need to hide the fact that we're not actually, the collider is not actually touching the ground. Okay, I didn't notice anything, and I think you probably wouldn't notice anything either. Yep, that's it. So I think our movement is done for pretty much everything we need, or any other third-person shooter series that you want. We do have a normal adaptation, so we do change the velocity based on the normal we are on, which is a major feature, and we also are off the ground, which means there's no small obstacle that can hinder our position. We can also go downwards and upwards without flying off, which is also everything we basically need, to be honest, this far. So let's finish this part, because this is the best movement we can have, at least until we find any other issues. And there's of course a few other things that we cannot, but these are just mainly just polish on the controller we have. Okay, so I'm going to end this part now, and on the next one we're going to actually fix our camera, because I don't like Cinemachine. It actually breaks. It actually gives more problems than it fixes. Anyway, so as always, you know what to do. Like, subscribe, and if you like to see more stuff, more videos, more series of everything, then of course consider supporting me on Patreon so we can keep making all of these nice things we're making. I'll see you next time.